Hello grade 11s, good afternoon. Welcome back to another video. Today we'll be doing chemical bonding for grade 11s. Now, without wasting any more of your time, let's get right into today's video. So a chemical bond is bonding together atoms in a pair. Let's say, for instance, we combine O and two oxygens, right? We combine two hydrogens and one oxygens. This is a bonding, but it's also called a molecule, right? So a molecule is bonding two elements together. So that is chemical bonding. We are going to holding atoms in a pair. So this is a pair. Oxygen and two hydrogens, they make H2O, which is water. And that is a bond between them. So we have three main types of bonds. We have covalent bonds, which are between two nonmetals. We have covalent bonds, which are between two nonmetals. In the periodic table, you should know by now in grade 11 that you have metals and nonmetals. So when you have two nonmetals bonded together, it's a covalent bond. Just like hydrogen and oxygen, they are both nonmetals, so they form a covalent bond. And then we have ionic. It's between a metal and a non-metal. That is ionic bonding. Maybe when you have when you combine two elements or atoms, the other one is a metal and the other one is a non-metal, we have ionic. And then there's metallic, a single metal, and we don't have to worry about that one, just have to know the three types of bonds. And the metallic is a single metal. So we're going to be focusing on covalent and ionic bonds. And we have something that we call intermolecular forces. So that is a bond inside a molecule, right? We say two hydrogens and one oxygen make up a molecule. So if you try to separate the oxygen from this hydrogen, those are called intermolecular, we're talking about intramolecular forces. It's bonds inside a molecule. So a molecule can be two or more atoms bonded together. So saying to separate this O from this H is intramolecular forces. And this is a covalent bond. So we also have something called electronegativity. Now, this is which atom needs more valency electrons and those that don't need. I hope you know how to do your Lewis structure. It will help you with understanding this. And then we have covalent. When the electronegativity between two atoms is less than 2.1, they are covalent. There's a covalent bond. And when the electronegativity is more than 2.1, they are ionic. And then we also have polar molecules. It has a negative and a positive atom or element. And then we have nonpolar, where they are balanced. Let's see the difference. Let's try to bond hydrogen and fluorine. Hydrogen is in group 1, so it has one valency electron. Fluorine is in group 7, so it has 7. 1, 2, 3, 4, 5, 6, and 7. So F, which is fluorine, wants to be fully surrounded. So H will give up its valency electron to fluorine, so that fluorine becomes fully surrounded. So which means valency electrons are negative. So fluorine will become more negative, while hydrogen becomes positive. So we have a negative and a positive element, and this make up polar molecule. But then when we have a hydrogen, which is in group 1, bonding with another hydrogen, which is in group 1, this valency electrons will just be bonding. No one is sharing their valency electrons because they are exactly the same. So we'll have hydrogen like that. The valency from this one will bond with this one. And then this is what we will call a non-polar. So oxygen is in group 6, so it has 1, 2, 3, 4, 5, 6 valency electrons, and hydrogen has 1. So this hydrogen will give its own valency to this one, and then we have to create one more oxygen so that it bonds with the other valency electrons. So this is how we have H2O, and this is still a polar molecule. So this one will bond to this one will bond in this. So you will have something like CaO like this. So this is a double bond. Here we have the intermolecular forces. So dipole forces are two polar molecules, and then dipole forces are between two molar molecules. That can be the molecule of H and Cl, and another H plus Cl. So they are both two polar molecules, which means the other one will give up its electrons for the other, because the Cl is in group 7 and the H is in group 1. So the H will give Cl its valency electrons. This one will be negative and this one will become positive. So they are polar. And then the second one, mutually induced dipole forces. These are also called London bridges. Not London forces, not bridges. So mutually induced dipole forces, between two nonpolar, they are London forces. London forces are the weakest forces, and then dipole forces are slightly weak, but hydrogen bonds are very strong. So an example of mutually induced dipole forces, we can have an H and an H. So this, we said they are polar. So London forces are polar molecules. Yes, they are London forces, very weak. And then we have dipole induced dipole force. It's between a polar and a non-polar. So here you can have HCl. This is the molecule bonded with H and H. So this will be a dipole induced dipole. And then we have ion dipole force between polar and non-polar. So that will be H and then Cl. And then it will be bonded with Na that has plus ion at the bottom. This is an ion. And then for ion induced dipole forces, it's between, this is a polar, this is an ion with the plus on top, and then we will have ion induced dipole forces where it's H and H for non-polar, and bonded with Na plus. So this plus, this charge is ionic. So when you have this charge, just know that is an ionic. This is how you will know. So electronegativity is that smallest number on your periodic table. So when you are given two elements, to know whether they are whether they are covalent or ionic bonds, you have to add their you have to minus the bigger one's electronegativity from the smallest one. And if the answer that you get is less than 2.1, that is covalent bond. And if it's more than 2.1, that is what we call ionic bond. Thank you very much, guys, for watching. Until the next video. So before we close this video, I forgot to say that intermolecular forces are forces between two molecules. So this is a molecule, this is also a molecule. So we are trying to separate the bonds between these two molecules. And hydrogen bonding is when hydrogen is bonded with oxygen, nitrogen, or fluorine. If you look at the periodic table, they are right next to each other, so they make a very strong bond that is very, very difficult to break. You will need high temperatures to break this. Thank you guys very much.